You will be provided only data samples, no labels. Labels will not be provided. Now, see for example, this kind of a data. This is a simple 2D data. So we have some variable x1 here and some variable x2 here. It's a spread of some samples like this. Now, if I ask you how many groups will you see in this data? Since you can visualize this data, you may say, okay, I can group this sample, these samples, these samples, and this sample. So there may be k equal to 5. So k here in kmeans stands for number of clusters. So k equal to 5, that means I am interested in 5 clusters. Somebody may say, okay, I will consider these samples into one cluster, and then I can make, instead of 5, k equal to 4. So there is actually no such fixed thing, since this is unsupervised learning. There is no label provided to you. So answer with k equal to 4 is also correct, k equal to 5 is also correct. But there are some criteria where we will see at the end of this lecture how we can decide k. So in k-means clustering, so it is really k-means. Its meaning of k is cluster. So don't get confused with earlier k and n. That is k nearest neighbor. So k nearest neighbor, we have seen two things if you remember. One is estimation and other was k nearest neighbor rule. So this was used for classification and this was used to estimate probabilities or likelihood. So nothing to do with that. This is purely unlabeled data. So some random mixture is given to you, then you want to segregate that mixture into different groups. That is our task. Now how we do it? So let us see what k-means is. So first of all, we start with assumption of k. Since I don't know what should be value of k, that is how many, say you can write in short, k stands for number of groups you are interested in. Okay. I want 5 groups from this data, so my initial assumption is k equal to 5. So that is the beginning of my algorithm. You may start with k equal to 2, you may start with k equal to 5 or 10 or whatever you want. Can you start with k equal to 1? That means I want everything in one group. So there is no fun in doing this, because for clustering, at least the minimum value is 2. Because you will be dividing this data into at least 2 groups. Everything put into one group, that doesn't make any sense. So minimum value of k is 2. Maximum value, how much you can go on making the clusters. So at the most you can go up to the number of samples. So this individual sample you can make a small cluster. So if I want I have to do 10, and if I make every sample as cluster, then maximum k can be 10. I cannot have 100 samples and k equal to 500. So this is not possible. So no empty clusters allowed. So you cannot have empty clusters, or you cannot have everything into one cluster. So that are the extreme cases. So that are not allowed. So what can be value of k in k-means cluster? So k is minimum is 2, maximum is number of samples. So this thing you keep in mind, that I cannot have groups more than available samples. Now the second step, after assuming that k is equal to 5, we randomly assume 5 cluster centers. We just use some random process to initialize random cluster centers. So we don't know what is cluster center right now. We have not seen data also. Just since I want 5 clusters, I am making assumption of 5 cluster centers. So if you can see these red dots, these are some random assumptions. We have not seen data. So currently we can see this data, but suppose you have 10 dimension or 15 dimensional data, then you cannot visualize the things. So there we just randomly assume our data points. Here also I am doing randomly, and I am showing you with the original data and this randomly assumed cluster centroids are superimposed on that. You can see they are just thrown randomly on this sheet, and we will proceed for the third step. So what was first step? First step was to assume cluster, number of clusters as per our requirement. So here I am saying k25 is my requirement. So I have some idea that there are 5 groups in this, so I'm just making it k equal to 5. Then second thing I'm doing is, once I know I am interested in 5 groups, I am declaring or randomly assuming 5 cluster centers. Now based on this, what happens is you have partitioning of data. We have seen in KNN also there is a partitioning of data once you know the centroids or the cluster centroids of your data. So here, this is my randomly assumed cluster centroid. This is randomly assumed. These are 5 randomly assumed. Based on that, when you go with minimum distance algorithm, what happens? Suppose I put here a test sample. What you will do, you will find out distance of this test with all these 5 centroids, and then you will see that which is the closest centroid. So by default, this will be the closest centroid. So I will assign this X test with this group. Okay, so if I keep on doing like this, then you will see that on this boundary, I have this distance and this distance same. So I cannot assign any group to this sample. No doubt these remaining clusters are far away, but there will be a tie between these two groups. So that is the boundary between two groups. So you can see if I join these 2 points, then this perpendicular line becomes the boundary between two classes. Similarly, if I join these 2 points, then perpendicular to this becomes the decision boundary. So like that, these boundaries are constructed for all the 5 centroids. So this becomes group number 1, this becomes say group number 2, this is group number 3, this whole thing is 4, and this whole thing is 5. So now the space is divided into 5 groups as per our requirement. But no doubt these centroids are not proper and they are not representing true centroids of our data. So what is to be done? So we will go to the next step. Here we compute new centroids for the partition data. So as we have seen, we have this group, suppose group number 1. Then what we do, we find out a new centroid for all the samples which are in this group. Then we find out centroid for all the samples which are falling into this partition. Similarly, we will find out centroid for group 3, group 4, and group 5. So for each group, we find new centroid. Okay, I just repeat. We started with k equal to 5. Then we started random assumption of 5 centroids. And based on those 5 centroids, we have partition of space, and then we calculate new centroids for each partition. So what happens? So this data brings this centroid towards this side. So this is my new centroid for group number 1. Similarly, this is the group 2, and this centroid which was randomly assumed space, actually this is empty space, which is balancing these two groups. Okay. So you can say an average position will be here. It's a centroid of these partition 2. So this is a new position of group 3. This is new position for group 4, and this is new position for group 5. Now centroids have changed. Initially they were randomly assumed, but based on that randomly assumed, we have some partitioning of data, and based on that, we have calculated new centroids. Now, once you have new centroids, you have now new boundaries. So earlier boundaries are here. So this is group 1, group 2, group 3, group 4, group 5. Okay. So this is now the current state. Now what is to be done? Sixth step is repeat the above procedure till your program terminates and there is no swapping of samples from one cluster to the other cluster. You can see here so once I randomly assume centroids, this was my centroid. These are my centroids for each group. Okay. Now, once I change the centroids, you will see some portion of your, you can see this particular portion, you can see on your screen. Say this was, since there was a shift, the earlier samples belonging here are now shifted to this second group. So you can see because of this, lot of things are happening. So this was initial group for number 2. Since my centroid has shifted here, you see lot of samples which were earlier belonging to group 2 are now being shifted to group 3. Okay, since many samples are getting shifted because of this shift in centroid, we need to recalculate centroid. And we will do this procedure of shifting the samples and recalculating the centroids till there are no shifts. Okay, till there are no shifts. So if you keep on doing these things in a loop, you will see that your centroid is settling to the proper location and you get 5 proper centroids. Okay, so this is how this simple method works. And suppose you put k equal to 4, what will happen is, instead of these two things as a separate, we will have somewhere here a fourth centroid, and this will be in one group. So pictorially, this is not a good thing that you will be keeping a centroid at such a location where there are very few samples. So centroid must be surrounded by many samples. So that's why it will be a centroid of the data. So it should represent, or it is a prototype for certain group. So for example, this is the location where I am storing feature of character A. This is the center where I am storing character C. This is representing B. So this is representing suppose Z, and this is representing some letter J. Okay, so these are 5 things with me, and suppose I write something like this as a new character which is to be classified. So maybe this is where this sample is. Then you will find out distance with this group, you will find distance with this group, you will find distance with this. All centroids you will take into account. And then you will say that this input X test belongs to this group C, which is the closest one. Okay, so this is how we are going to use this particular algorithm. We will start with random assumption of k, then we will start with random assumption of centroids, then we will calculate new centroids based on the partition, then we will do this procedure till there are no shifts in your data. So we will take one example and then it will be, I think, how exactly we do it. Now let us have simple 4 points so that things are made simple. We will not make the things complicated. So we have just 4 samples. Sample A, sample B, C, and D. So if I plot that on, say, XY plane, say A is here, B, C, and D. As a first step, assume that I want to partition that 4 samples into 2 groups. So is, and then the first step is to randomly partition this data into two groups. So here, how we implement, you see here carefully, uh, the problems will be based on this type of methodology. So here, this is called as partition matrix. So that we will assume. So G0 is the partition matrix, and entry here 1 means that the sample A belongs to group number 1. Entry 1, 1, 1 here, it means samples B, C, D, they belong to group 2. So this is my random assumption, initial guess. I don't know, I have not seen any sample, but I am just randomly assigning or making this matrix. It means that I am randomly assigning centroids for each group. Now how I am doing that? So based on this random assignment of each sample to a certain group, we can calculate centroid of that. Now see carefully that this matrix has two rows. Two rows, they stand for k equal to 2. How many groups you want to make? Suppose I want to make 10 groups in some problem, then there will be 10 rows to this matrix. How many columns you have? Number of columns equal to number of data points. Okay, so for each data point there will be a column, and for each column there will be only one entry of 1. That is, the sum of this column is always equal to 1. You can't have multiple entries for same data point. That means if I write here 1, it indicates that A belongs to group 2 as well as group 1. So that is not allowed. You assign to anybody, but it should be assigned to only one group. Now determine the centroid. Knowing this table, you can find out centroid. So you can see that group 1, so group 1 is here. So there is only one sample, that is sample A in group 1. So the centroid will be same sample. So C11, that is centroid for group 1, is 11. Now group 2 has 3 samples, B, C, D. So its centroid is the average point of these 3 samples. You can see here. So we have to find out average of these 3 data points. Just add x-axis of those 3 samples and add y-axis of these 3 samples, then divide by 3. The same thing is shown here, 2 plus 4 plus 5 by 3, 1 plus 3 plus 4 by 3. So this will give you C2. So C2 is 11 by 3, 8 by 3. Now find the samples to centroids distances. So once you have obtained new centroids, so these are new centroids, you find out distance of sample A to group 2 and group A, distance of point B to group 2 and group A, like this. For every data point, you will find out distance with each newly calculated center. Okay, so you write that in this matrix form. You can see the distance here is 0 because C1 is itself is a centroid, and 3.14 is distance of this 1 to this C2, that is 11 by 3 comma 8 by 3. Once this is done, our table is complete. Then we will do this reassignment of samples from one group to the other group. Now see, this is G1. Earlier it was G0, which was 0, 1, 0, which was 1, 0, 0, 1, 0, 1, 0, 1. So this was a random guess. Now, based on this calculation, what we observe is that point number B is more closer to group C1. Its distance with C2 is more than C1. But we have assumed this point B earlier belongs to group 2. So this needs to be swapped. So you can see that we have swapped this here. So we have changed the position of sample B from group 2 to group 1. Okay. For remaining, you can check. This is the minimum distance. So here you will see 1. Then this is the minimum distance. So here you will see 1. And this is the minimum distance. So you will see 1. So for rest, there is no problem. Only problem was with sample B. Now, since we have changed the sample B from group 2 to 1, now group 1 consists of 2 samples. So earlier it was consisting of only 1 sample. Now it has 2 samples. So we have to change the centroid. So this is new calculation of centroid. And since 1 sample from group 2 is shifted to group 1, its centroid will also change. So accordingly, we calculate a new centroid for group 2 and new centroid for group 1. What is next? Next step is again find out distance from each sample to these two groups. Okay, and write neatly in a table. So here you can see that A distance of A with group 1 is now 0.5 because centroid has shifted to some new position, that is 1.5 comma 1. So earlier it was 1 1 for group 1, now it has become 1.5 1. So obviously there will be some distance now for group 1 for 0.1. So this has 0.5 for 0.3, this is 0.5, 0.54. Okay, so like that we have calculated distances for all, and these are our new centroids. Now what is next point? Next point is to again calculate the matrix, group matrix. This is G2. You will see that this is group 1 and this is group 2. There is no change. Nobody has changed the position. So they are now settled to 2 groups. So G2 is equal to G1. So if we achieve this position, then we will stop the algorithm. Okay, so I just repeat the steps. We randomly assume some initial value of k equal to, in this case, 2. Then we find out this group matrix G or partition matrix G. This is, remember, this is randomly assumed. You can start with some other matrix like 0, 1, maybe this as 1 and 0, and try this problem again. Okay. Now, is there any difference between, say, 0, 1 and 1, 1, 1, 0? If I use this thing instead of this group, is there any change? So there is no change because this group now called as group 1 and this group now called as group 2 has the same number and same number of samples and same number of and same samples. Okay, so there is no change actually. So we can call group 1 as group 2, group 2 as group 1. That doesn't matter. Only thing matters is what that group consists of. Okay, so first step is to randomly assume this and then calculate centroids. So once you calculate centroids, you calculate distance from each centroid to each sample. Okay, so that way computationally it is complex because we need to find out the distance, and here distance means we are using Euclidean distance. So that I forget to mention, we are using Euclidean distance. So distance between, say, x and y is x1 minus x2 square plus y1 minus y2 square. If your data is of n dimension, then you can write I equal to 1 to b, say x1 I, x1 I, then you can say so like that you can compute. The next thing is rearrange your groups. Once you calculate based on the minimum distance principle, you rearrange your groups and then you recalculate centroids. Once you recalculate centroids, again recalculate distances and see whether there is any change in partition matrix. If there is no change, stop. Otherwise, repeat the procedure since from the step number 2. Okay. This is how this algorithm is very simple and very effective. This is a sample code of kmeans clustering using sklearn. So if you want, I can give this code to you. Here, this part is randomly assuming some data points like this, and this part is displaying the samples. Now, in sklearn package, there is a very good command, straightaway command, kmeans. That's all. So we have to just initialize this object and pass on this data x to the command, okay, to fit the model, and you will get in turn written as a model based on kmeans. So it's a one step in the package, but if you write on your own, then you will find out the difficulty in programming. That way it's very simple, but still you have to struggle to have a proper answer. Now this is the earlier data, and you can see that we are plotting here corresponding centroids. So what is beauty of k-means clustering, say you have 1,000 samples and you are saying k is equal to 5. So once you group these into 5 sections, you just remember only prototype. When you want to test some data, you just need 5 prototypes. Since you have decided that you have 5 groups, so you will just remember 5 samples. This in this case, say k is equal to 3. So I'm just remembering these star points, and rest we can forget. We can throw this data. Just remember the star points, that is centroid of your cluster. Then if you have any test sample, say like this, just calculate distances with these centroids and take a decision. So that is beauty of this algorithm. Just you have to remember, after processing the data, just remember centroids. Now, how many clusters? How many clusters? So k is equal to question mark. So somebody say 4, somebody say 3, somebody might say 2, somebody might say 10. So which is correct? So there is a simple way to do this. It is called a elbow method. So we do this calculation of sum of squared errors of distribution. That means we find out the centroid for the given partition. Suppose I say k equal to 5. Okay, so k equal to 5. Then I have executed the algorithm and I obtain 5 different cluster centroids. Once I obtain that, then I calculate this distance from cluster centroid with each data point that belongs to that cluster centroid. Say this is cluster 1, this is cluster 2, this is cluster 3. Then I have some samples here, some samples here, and then some samples here. These are some centroids. So from centroid to each data point, I actually calculate distance square. Okay, this is nothing but norm square. So that is Euclidean norm square. So I will calculate distance between centroid and this surrounding point. So this is mu1 and some point xi. So xi minus mu1 whole square, that is the distance square. So that we will calculate for each training point with corresponding centroid. So you have some mu2 here, then you will calculate for some xj point distance square. So you will add all such distances of your training samples with their respective centroids, and you will try to minimize this sum of square error. Now, how you can do that? What is in your hand? In your hand, you have the variable k in this algorithm. There is nothing in your hand. Data is fixed. You cannot change the data. Okay. So samples are fixed. Only thing is you can play with k value so that these different mu's are generated. Okay. And you will choose such a value of k that this SSE is reduced. Now this is a sample code to do that. What we do here, we take a range of k. So k is here 2 to some 10. Okay, and then we execute this k-means so many times. Okay, we execute suppose for 10 times. Okay, we take the data, change value of k and fit it, and then measure the distortion. So SSE The sum of square of errors is sometimes also called as distortion. So distortion we find out and append it here. So one by one each value of k, and then we plot it. So what you see here is a graph of distortion versus this number of clusters. So initially, one should not go with this, but it is shown here that k is equal to say 1. This is not required. So you can start with k is equal to 2, and then you can see that this is going down and then going down and down. So when you go with k more than say when your k is reaching towards number of samples, then you will see that this distortion has reduced drastically. So we are not interested in making k equal to m. So if I keep on doing like this to the number of samples, then this may reach to 0, but that is not our interest. We want to group the samples, not to make every sample a group. Okay. So what we do is we take this elbow point as the ideal cluster. So this actually for this problem k is equal to 3, where you get this elbow is the right position, because further increasing k has reduced this value of distortion, but that is resulting because we have some extra clusters. So when you keep on increasing clusters, this value is going to get reduced. So we can say that this elbow position is the good number of clusters. So this is how we can decide best value of k for a given problem. So that's why the name given to this method or extension of kmeans clustering is called as elbow method. Okay, so let us start here.